Hello world, I have with me the Sunwa YX-360TR multitester. The packaging says fuse and diode protection, and it is a very old multimeter. I don't know if these things are manufactured by the Sunwa brand, the Japanese brand. This one came with the instruction manual. This is a very vintage multimeter. Let's look at it. It seems to be missing this optional accessory. If you want to see the manual, you may pause the video from time to time, but there isn't actually much to see except for this so the manual does say that it has a lot of functions, including the HFE factor or DC amplification test. It has diode test, continuity, and the usual AC/DC voltage, and also some amount of current. So I don't think we're interested in the instruction manual. Let's put it aside, also with the box. Let's look at the actual unit. As you can see, a piece has broken off from this, which I think I may repair with some epoxy. And through this we can see that in there is if you can see, there is a 9-volt battery. I don't know if you can see. I think we have to open this up. First, let's check if the battery is still alive. I don't think it is. So we're going to set it to any ohmic scale. Now the battery seems to be quite dead. Here is the continuity, also not really functioning. So I will try and open this up and take a look inside, and if possible give it a new battery. So I am in, and in for a horrible surprise. This thing looks like it has been scavenged from some garbage yard. I don't know if these batteries have ever been changed. And this is just dry cell. Oh my. I think this is quite dangerous at this moment. Just look at this battery, man. Let's take a look at this. Oh my god. Oh my god. Okay. Why am I doing this? Okay, let's see. So far, the contacts have not been damaged. This is a surprise. Well, they have taken some damage, but not much. If you can see that this, the place for the screw, it has broken off. so he had to bind it with some thread. And the PCB doesn't look bad, looks good. There is the buzzer. Looks good enough, not that good. But is this really manufactured by Sunwa? If anybody knows, please tell me. Leave it in the comments if you know, if you have used this multimeter before. It takes 3 batteries actually. Why? One 9-volt for maybe some function, and then 2 AAA, AA batteries. Let's clean it up and put some fresh batteries in it and see if it works. So while cleaning up, I opened the screw, and it turns out that there is a metal threaded insert in there. So this screw was meant to be opened and without damaging the plastic. Oh, I'm sorry if you haven't seen. Here's the metal threaded screw, and it was right here, and I think this is actually made by Sunwa. It doesn't look bad. It is vintage, but it's not fake. The parts look good, and I'm in the process of cleaning it. So I have cleaned it up a little, and I'm testing it by applying some voltage to the battery terminals and testing different functions. And it seems like the continuity testing is okay, but for some reason this LED has been attached the other way around. This is the positive, this is the negative, and for the LED this is the positive and this is negative. So they kind of put it the other way around. This mistake was made probably some decade ago. So as you can see, I have glued it with epoxy, and it's still drying. This is a fast drying epoxy, but still it takes a lot of time. So while troubleshooting it, and I'm doing it with the power supply, applying 3 volt on these 2 battery terminals. I don't know what the 9 volt is for, but most functions seem to work with the 3 volt or the AA batteries. So it seems that there is this ohmic scale X1, X10, X100, X1K and 10K. Now the X1, when I set it to X1, the dial, as you can see, I have adjusted the 0 on this left side, but on the right, even if I move this potentiometer fully, it just doesn't reach there. It reaches to 1, perfectly 1, and I think that's what it was supposed to do. And if I then go to X10, the continuity indicator lights up, and this time I can adjust it all the way to 0. It's a bit flimsy because it's a needle, but they have this mirror, if you can see this shiny mirror underneath this dial, that makes it easier to read. So it seems that it's not that bad. It is fairly accurate as a very cheap analog multimeter. So let's keep troubleshooting it and see if I find something else. So while testing it, I found that on this X1 scale there is something wrong. My power supply starts to draw about 270 milliamps when I short the leads, and I mean the power supply is currently replacing the batteries, the 2 AA batteries, and so simply if you were to just dial it on the X1 scale, and short the leads, then you'd end up burning up your batteries. I'll show you. So I was thinking which component was drawing so much power, and I kept touching these resistors, and I got a tiny burn. And then I used this glue stick to test that it was this resistor, and this is just melting the glue like butter. I don't know why. Let's do some more testing. So I have put a 9-volt battery on the 9-volt battery compartment, and I'm applying 3V on the 3-volt battery compartment. And the confusion earlier I had with this X10, I still have this confusion, but so far I have figured out that this X1 scale actually turns this into a power supply. Like if I were to short the leads, 270 milliamps would flow through it, draining all the batteries. But this is useful in one way. You can light up an LED. You can see the LED lights up. Here's the red one, and this can even drive motors. I have tried. So I don't know why they would put such a function in this multimeter. Actually, it's called a multitester. Pardon me for that. So far you can see that the functions such as the DC voltage measurement and the AC voltage measurement, these are, I hope, working nicely. I haven't tried the AC voltage because I don't have any safe level of voltage. I have directly 250 volt, which is the mains line, and I'm not gonna do that. And I have tried the DC voltage with a battery, and it worked. And also this ampere scale, the current measure, it also works. The 10x scale, ohmic scale here, requires a 9-volt battery. Actually, both the batteries. It requires both the 9-volt and the 3-volt. But the other other four just requires those two AA batteries. And I don't know the other things about it, why this is 150 milliamps and 15, 1.5 and 150 microamps, since there is already a current meter, an ammeter here, DC ammeter. I think this has some other functionality. Now I haven't read the instruction manual, and you can blame me for that, but then again, who reads the instruction manual? I'm just curious as to how this works. The circuitry is fairly simple. It's all resistors, some capacitors, some Zener diodes, and some potentiometers, and that's all, nothing else. As you can see, I have put epoxy on the parts that were damaged during the fall all those years ago. Also, I've put some epoxy here. Let's look at the dial of this thing. Now, I couldn't figure out if any of these readings were accurate. These ohmic scales, the AC voltage and the DC voltage and this other ammeter function, they work, but none of these seem to work. I put a lot of resistors here, 100 ohms and 1k, but none of them seem to work correctly. I'll try it again. This is the 10 ohm resistor. So if I were to scale it to 100, then should I, like, I don't know how this works. Let's test. And it gives me absolute 0 rating. Let's first adjust this. And even this potentiometer doesn't quite work well. This thing is too old. Okay, I think it's, see, I have shorted the lids, but for some reason it's not working. There is a high error rate. Still shows me the same. If I short it, it's the same. If I put a 10 ohm resistor through, come on, it's the same. If I put a 1 kilo, then it goes halfway. But this is the 1K, so let's put the resistor on 10K, and it shows me a dead short. Well, every time you have to do this. Okay, the zero adjustment is done, and it shows me a short. I just don't understand. Either I don't know many things about, either I don't know anything about analog multimeters, or this multimeter is a non-functioning one. There must be some hidden layer of information that I don't seem to know. Like, why would they put 4 different scales and none of them would work like close to what they're supposed to? This is a 1K, so if I put the 1K on the 1K, then I should at least go at some extremes, like either it's gonna be here or here. Let's test. None of the extremes. Is this even calibrated? Okay, it is not. Zero adjustment again, every time. Just take a moment to appreciate that 2 decades or 3 decades ago, people used to work with these things, and they achieved so much with these. So hats off to them. Still, I am nowhere to the close to the extremes. Okay, I think I understand. If I put it on 1K and then measure it, and if it lands on 1, then am I supposed to get the reading 1K? Let's test that. So I have 100. If I put it to 100 and then test it, I still get 1. Does that mean it's 100? What if I put a 220? Is it gonna go to 2 point something? Yes. Alright, so as far as I understand, if I put it to the X100, so every number I get, I'll have to just put the 100 after it. So here it is. This is a resistor that is showing me on the scale it's 2, and I just put 2 zeros after it, so I get 200, and this is a 220. Now you can't really tell that it's 220 from an analog multimeter because it doesn't give you the number, it just gives you a reading. Yes, I think I understand it now. This gives me 1, this gives me 2. I'll just have to put 2 zeros after it. Let's try. I hope this is a 330. Yes, it gives. Alright, so here's what happened. I bypassed this the line of this resistor. These wires, you see, these go to the LED, and I just pulled one part of the resistor out by heating it up with a soldering iron, and then connected the positive terminal here and the negative with this resistor. Earlier the batteries would directly connect across this resistor. Now there is an LED in the middle of the circuit. So what happens is the original function is now working. Earlier on the times 10 scale you would get the continuity indicator lighting up, but now it does what it used to say, I mean in the instruction manual. Now the continuity lights up when you put it on the x times 1 scale. In case you didn't see that, under this scotch tip, I mean this masking tip, there is just a solder joint connecting this negative terminal to the LED and then the positive terminal to this contact point, and this contact point is actually the times 1, so the continuity is lighting up. As you can see, the instruction manual says that there is the continuity test bus and the continuity test LED. So it says to connect to the bus, and also in this LED mode it says cont apostrophe Y. So this was the cont apostrophe Y or continuity, and this is the buzz. If you can see, this is the continuity and this is the buzz. So it was a manufacturing defect. So with all that said, I hope this video is about at its conclusion. So hope you like this video, share your thoughts, and hope to see you next time.